Okay, ready? Here we go. So the only difference between what we've done before this week, this whole entire week, and what we're doing now is we're doing the same thing, except now we're going to identify the type of reaction it is. Because there's 5 types of reactions that can be identified based on the number of reactants and products, or based on what the reactants and products are. Okay? So our 5 types are combination, decomposition, combustion, single replacement, and double replacement. Okay? We're on page 3. So, we're going to go through, I'm going to give you an example equation. If you would like to write down the equation, you can. It's not necessary, but it does help you to try and identify. The equations do have states of matter, which don't matter right now. Okay? You will have to write them yourself, but if you want to write down the reaction, you don't have to write down the states of matter too. Okay? So the first type is a combination reaction. This is where you have many reactants that react together to form one product. So the biggest identifier to know that it's a combination reaction is that you only have one compound on the product side. So there's only one product. Like for this example, there's MgO. This is the only thing on the product side. So this is where you have to remember reactant side is left, product side is right. Okay? Because if you don't, that will mess you up. So for combination reaction, I like to abbreviate it as combo. If you come up with another abbreviation, that's fine. But just know that there's another reaction that starts with comb. So you got to be careful there. Okay? So that's combination. Only one product. Decomposition is the opposite, where it only has one reactant. Okay? So decomposition is when you have a single reactant, one reactant, that breaks down into many products. So the HGO there. Okay? The one reactant is usually very complex. Not in this example, but in many cases, you have polyatomic ions as a part of the reactant. Yesterday, the hydrogen peroxide reaction we did in that lab, that was a decomposition reaction. Because you only put one thing into the reaction, and you got out many different things. Okay? So decomposition, you see the one reactant, and that tells you it's decomp. So for decomposition, I abbreviated decomp. So you can think about it like if you're decomposing organic material or you're decomposing a body, it's breaking down over time, right? So that's a way to remember decomposition breaks down. Okay? So combination and decomposition have one reaction or product. The next 3 have 4. So with the 4, they can be a combination of different things. So there's 2 reactants and 2 products. I know it's doing this. It's okay. It'll come back. See? It came back. So the first one we have is a single replacement. So I abbreviate this one SR for single replacement. A single replacement, you have 2 reactants and you have 2 products. Okay? This is the hardest one to identify for most people. Because on the reactant side and on the product side, we have things that are by themselves. They're single. So it could be like copper or aluminum or like an element that's just by itself. Or it could be a Hunkel fiber element too. But Hunkel fibers do apply here. So it could be like hydrogen gas, H2, or something like that. Okay? The other reactant is a compound of some sort. Okay? So then when you get to the product side, you have a compound and a thing by itself again too. So we have another compound and then we have another single. Or Hunkel fiber. Diatomic molecule. Okay? We are going to, starting next week, learn how to actually predict what the products will be if I give you 2 reactants and I say it's single replacement. But for now, we don't need to know that. Okay? We just have to be able to identify it once we write it out. So we have a a single and a compound on the left, and we have a compound and a single on the right. It could be flip-flop though. You could have the single first and then the compound second, or vice versa. It's okay to have it mixed around. It's just you have the single by itself and you have the compound. Okay? This one's the most difficult for people to understand. Next, we have double replacement. So single replacement have things singly or by themselves. Double replacement have all compounds across. It's still 2 and 2, but all of the reactants and all of the products are compounds. Okay? So this one is sometimes the easiest to identify, and this one is used the most often because we have compounds and compounds and compounds and compounds that we can react together. Okay? So the way that you identify a double replacement is compound. Since I abbreviate decomposition as decomp, I abbreviate double replacement as DR, if you want to use my abbreviations. And the last type has 4 as well. The last type is our combustion reaction, so we're burning things. But I have 3 different ways for you to identify what's a combustion reaction. Okay? Don't label a combustion reaction as combo because that's combination, right? So, a combustion reaction happens when you have something react with oxygen. So usually it's oxygen from the air, okay? So a way to identify that is oxygen gas will probably be a reactant, okay? Because it's burning with the oxygen. That's one way that you can tell it's combustion. Another way that you can tell it's combustion is if you only have elements of carbon, hydrogen, and oxygen. These are the headache ones, right? When you're trying to balance it and you're like, oh my gosh, I have an odd number of O's and they add together. What do I do? How do I get this to work? You guys know what I'm talking about? So, if you only see C's, H's, and O's, that could tell you it's a combustion reaction. Hint on balancing these. You always want to do carbons first, hydrogen second, and then oxygens last. Because if you can get the hydrogens and the carbons to work, most of the time, like 50-50 of the time, the oxygens work. When you have an odd number of oxygens, I have a magic trick. So if you ever have one of those, I'll teach you the magic trick and it magically works out. Okay? The last way to tell that it's a combustion reaction is when you have the same products every time. This could be like a test question. I'll say, what are the products of a combustion reaction? And you would always say CO2 plus H2O. Carbon dioxide and water are always the products when you have the C's, H's, and O's for a combustion reaction. Okay? So those are 3 ways to identify the combustion. And that's it. So we're going to do example 6, where we write out an equation, and then we are done with notes. So all we're doing is we're adding on so that you look at what you have and identify which type of the 5 it is. Okay? Nothing new with balancing or writing in it yet. Here we go. So we need to write the equation and then classify it for the reaction between aqueous potassium iodide and lead-2 nitrate to form solid lead-2 iodide and aqueous potassium nitrate. So, we did this one yesterday in our lab, by the way. Do you guys want me to go through the labeling, like these are reactants, these are products? Do I need to? No? Okay. So we'll just start at the beginning because we know the beginning ones are reactants, right? So the first thing we come across is potassium iodide. What's the charge on potassium? +1. Iodide stands for iodine, which has a -1. So that's just Ki. And it's aqueous, so we need to put a little AQ there. And lead-2 nitrate. What is the what does the Roman numeral 2 stand for? +2. I kind of said it, didn't I? So we have Pb +2. Yep, nitrate is NO3 -1. So we have Pb, then put NO3 inside the parentheses and 2 on the outside. It's kind of hard to tell, but this is also aqueous. Okay. To form, what does that mean? arrow. Okay. Then we have lead 2 nitrate. So we still have the Pb plus 2 combining with now the NO3 minus 1. No, just kidding. Did I write this wrong? No, I'm just looking at the wrong part. It's iodine. So it'd be Pb I2. Does anybody like, what is she talking about? She's crazy. Because that's how I felt. And it's a solid. And potassium nitrate. Does anybody remember what that is from yesterday's? What? KNO3. KNO3? Remember? And that's aqueous. Alright. Next, let's do a quick balancing of it. What should I balance first? Put a 2 in front of the K1 over 3 over here because we have 6 and 2, and so you need 6 and 2, so we gotta put 2 there. K. That makes 2 Ks. So 2 in front of the Ki makes 2 Is, and that's alright, right? It's balanced. Alright, now let's go through our 5 to figure out the type to classify it as. Okay? So we'll start at the beginning. Combination. You have one product. Do we have one product here? No. Do we have one reactant? No. We have 2 and 2. Do we have C's, H's, and O's only? No. Do we have things by themselves on either side? No. So yes, it is double replacement. I'm going to put DR for double replacement. Okay? So that's it.